Hello there and welcome to Lesson 12 in the series to learn programming in Scratch. Today you're going to do calculations and compare the answers with if blocks. Water is one of the most precious natural resources on our planet. Water is essential for the survival of people, animals and plants. Being water smart is vital in a dry country like South Africa. To catch rainwater that falls on our homes' roofs and save it in a tank for later use is easy. All you need is to connect the gutters with the tank. Rainwater tanks are available in several sizes. The choice of the tank depends on the area of the roof where you will collect rainwater. The tank water is an excellent source of water for irrigation since rainwater does not contain all the chemicals added to tap water. You can also use harvested rainwater for laundry, toilets, to top up the swimming pool water that is evaporated, and to wash the car. Another advantage is that your municipal water account will be lower if you use rainwater where you can. When we harvest rainwater, we also reduce the amount of stormwater that can overload the stormwater system after heavy rains and prevent erosion. Now answer the questions in your workbook. In the previous lesson, you've displayed the value of variables on stage. You can also use the say blocks to give the result. You've used the say blocks previously to make speech bubbles appear at the sprites. However, when you want to combine words with the answer of a calculation or variable, you need a join block. This light green join block connects numbers or words to form an expression or a sentence. For example, if you want to display the score but add a label score for Team A, you can also use a join block inside another join block to connect more than two things. For example, here you display the label the volume of the tank A is, the actual variable value, followed by the unit. Sometimes you want to do different things depending on specific tests or conditions. The light green pointed blocks from the operators group are used as conditions. This light green block tests whether the first value is equal to the second value. The block is used as a condition that can be either true or false. This light green block tests whether the first value is smaller than the second value. The block is used as a condition that can be either true or false. This light green block tests whether the first value is bigger than the second value. The block is used as a condition and can be either true or false. The orange if blocks are used together with the light green condition blocks. This orange block tests the condition and carries out the blocks inside the C space only if the condition is true. For example, write code to display the word distinction if you get 80% or more for a test. Create a variable named percentage. Use the ask block to input your test mark and the set block to save the value in a variable. Link the if block to the ask block and the set block, and then drag the greater than condition block into the if block's opening. Drag the variable's value into the first opening of the condition and type in the value for the second opening. Drag the say block into the if block, and then when you run the code and enter percentage of 80% and above, the sprite will display a speech bubble with the word distinction. If you have 79% or less, nothing happens. This orange block tests the condition and carries out the blocks within the first C space if the condition is true, and it executes the blocks within the second C space if the condition is false. If there is an obvious alternative, you can use the if, then, else block. For example, write code to display pass if you attain 50% or more for a test and fail otherwise. In this example, we use the if, then, else block because if the condition is not true, there's only one alternative. If there are more than two options, such as winning, losing, or a tie, you can use the if-else block inside the else part of another if-else block. For example, if the first condition is true, Team A has a higher score than Team B, the else part is not executed at all. If the first condition is false, the second condition is considered. Today's assignment is as follows. Create a program in Scratch and draw a background with two tanks. Save the program as water tanks. Input the radius and the height of tank A and tank B in centimeters when the green flag is clicked. Then calculate the volume of the two tanks in cubic centimeters. Display the volume of the tanks in the format tank A is 1000 cubic centimeters and tank B is 2000 cubic centimeters, for example. Compare the volume of the two tanks and display a message that says which tank is the largest and how many liters of water this tank holds. Here is an example of what your program might look like and how it might work. Follow the problem-solving cycle again. Investigate what you need and intentionally think of alternative solutions and be creative. Write down any questions you have about the assignment. For example, find out how to convert cubic centimeters to liter. Brainstorm potential ideas for the solution with your friends. How will you name your variables? How many buttons do you need? You can do everything on the when green flag is clicked, or you can use one button to do everything, or separate ones to input data, calculate answers, and output the results. Now sketch the layout of the sprites and the pictures for the stage. Write down the steps to code, including the input you need, formulas that will calculate the answers, and how you will display the output. Follow your algorithm to write the program and test constantly to check if everything is still working. Do you remember Eduardo de Bono wrote the book about the 6 thinking hats? Use this method again to reflect on this lesson. In the next lesson, you will program a sprite to follow a line. You will use the same principles that I used to code line-following robots. Until then, goodbye.